Hi everybody. In this video, I want to show you how you can take information from our folder from this week, which basically is in our Schoology page. Um, and it's the red folder that's basically marked chemistry the week of September 20th, and how you can use basically the front of the periodic table and our orbital periodic table picture to be able to pair those and do a shorthand electron configuration. Right? So I basically took the front of the periodic table. So if you click on this, you get a PDF of the front of the periodic table. Kind of looks like this. Has some writing up at the top because it's one that I actually used last year. But I'm going to use it to kind of talk you through how to do a shorthand electron configuration, right? So some of you may know how to actually do the shorthand electron configuration, but there's been more than a couple of people who have been absent, and it's always kind of a great review if you happen to need it, okay? Especially now because we know we are going to have final exams first semester. So how does the shorthand electron configuration work? All right. The shorthand electron configuration, or what they call the noble gas configuration, is indeed that. It is much shorter than what our traditional, what we call longhand electron configuration would be, which kind of documents all the electrons that are in a particular atom in terms of what energy level they happen to be. And we normally kind of indicate our energy levels. I'm doing this kind of along the left-hand side, but our periods, rows, or energy level are the way that we indicate where we are when we are going from left to right across the periodic table. And then within each of these particular energy levels, we also said that there are sublevels or orbitals, basically places that electrons could be, or electrons could be traveling. And so on the other kind of orbital or periodic table that we actually said is that we said that anything that was along the left-hand side of our periodic table would be traveling or hanging out in what we called the s orbital. All right. Anything that was kind of in the middle of our periodic table, right here where the transition metals are, basically from families 3 to 12, that those would be electrons that we could find in a d sublevel or a d orbital as marked in our orbital and periodic table drawing. And then anything that was on the far right other than helium, which is an S, would be in the p portion of a sublevel or the p orbital, right? And that kind of corresponds to this region that's right here in our periodic table. And then the rare earth metals, which are down below, are in the F sublevel or the F orbital, but we are not worrying about that in case, unless you want to, unless you want to kind of do some extended learning or enrichment learning on that particular sublevel or orbital. Okay, so how do we take all of that information and use it to create an electron configuration that is indeed shorter than our traditional longhand one, right? So for purposes of these video, or like this video, I am going to show you how to do the shorthand electron configuration for silver, element number 47. All right, how does it work? Because writing out the traditional longhand electron configuration, which would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, because remember that our d's sit an energy level behind, 4p6, 5s2, 4d9 is a lot to write out, okay? So what we do instead, first thing is, and silver is actually written right here And so we are going to start off, as all shorthand electron configurations do, by putting a set of brackets down, right? So once we have a set of brackets down, we got to figure out what element can go inside the brackets to start our shorthand electron configuration. The only elements in a shorthand electron configuration that can go in the brackets are elements from family 18, which we call the noble gases, right? The reason that we choose the elements from family 18 or from the noble gases is because they are one to the far right, but they are only, yikes, the only elements that have completely full and stable electron configurations. Okay, so as we actually go across the periodic table from left to right, different elements are going to gain all of the things that they actually need to make a complete and stable electron configuration. But because the noble gases are on the far right, they're the only family that have that. So we have to choose an element that's going to go in the brackets from that family. Now the question becomes, which one do we choose, right? So the rule for that is that for any element that you're actually doing, you are always going to choose the noble gas that is closest to it, but that has an atomic number that is less than the element that you are working with. So in this case, we're working with element number 47, which is silver. And so if we go to family 18, all right, we have noble gas Xe and we have noble gas Kr, right? But noble gas xenon has an atomic number of 54. That's higher than 47, so we can't choose it. So we have to choose krypton that is close and has an atomic number that is less than 47, because krypton's is only 36, right? So we're going to put krypton in our brackets, all right? And what that basically does is it buys you or allows you to be able to pass all of the elements that you would write in your traditional longhand electron configuration all the way down to krypton, right? So krypton in brackets basically includes everything in an electron configuration that would get you to krypton, okay? So now what do you have left to do? You just need to fill in the gap. Basically, what comes after krypton, and then we'll get you to silver, all right? So after krypton, you're at element number 37 and 38. Neither one of those are silver. So you can say, yes, they're on the fifth energy level. Okay. If we go to our orbital in period one, so fifth energy level, all right, we're in the S sublevel or the S orbital, and neither one of those elements that are on our periodic table are silver. Okay, Rb is rubidium, Sr is strontium. We're just going to jump to the end of that particular orbital, and that orbital would tell us that it's S2. So we are going to write down, all right, we already have Kr in brackets, so now we're going to write 5 for the fifth energy level, all right? And then we're going to write S2 for the electrons that are in that sublevel. And then we're going to go on. Now remember that when you get to the d orbital or the d sublevel region in your periodic table, those electrons don't have as much energy as the ones that are in the s orbital and the p orbital. So we normally indicate that by saying that they set an energy level behind. So even though we're in the fifth energy level for S and P, we are only in the fourth energy level for these electrons that are in our D sublevel on the periodic table. All right, so we're going to put down 4. There we go. And we're going to say that we are in the D sublevel. That is awful. Here we go. We'll try and make it somewhat legible. But we'll try again. A little bit better. Okay. And if we don't remember that it's D, remember that you can use our tool to be able to say, here is the region that we happen to be in. And now if we look at our periodic table, silver is in this region. Okay. It's one of these 10 elements. So the question just becomes, which one is it? Okay. And so all we have to do is count. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it is the ninth element. All right. Or it would have 9 electrons that are in the 4D region. Okay. So the shorthand electron configuration for silver is Kr 5s249. How do you know that you're right, or at least that you have a logical shorthand electron configuration, right? So you might remember that I told you that you could check the whether or not you have a right answer, or at least a logical one, by using these little numbers that look like exponents but aren't. They're just telling you how many electrons you happen to have in a particular sublevel or orbital. So if I take 2 and 9 and I add that together, I get 11. And any logical person is saying, well, 11 is not the atomic number that we have for silver. That's 47. So how are you going to actually check to make sure that this is right if those numbers only give me 11 and not 47? Okay, so in a shorthand electron configuration, because it's different than a longhand one, where you can use the longhand and all you have to do is kind of total up the number of electrons, and it should equal the atomic number, because in an atom your electrons and your protons are equal. Here you have to add in the atomic number of the noble gas that you put in brackets to actually start with. All right, so in this case we put krypton in brackets, and krypton's atomic number is 36, and if we add 36 plus 11 we get 47. Okay, so that is always a way to actually be able to check, just to make sure that your shorthand electron configuration is logical. All right, so again, this is how you would do a shorthand electron configuration. You should have some practice that you can actually do, and you can show me if I'm your teacher, or if you're watching just as a supplemental video. Make sure that you actually check and do some practice problems from the resources that you have available, and then use them to kind of check in with your teacher and get feedback about your progress from him or her. Thanks so much for watching.